Hello and greetings. My name is Jason Anamong. Alongside with me are Dominic Aurana Jonas, Brony Melantika Anagret, and Frederick Sarek Anapita. Today we'll be presenting about sand replacement. The aim of this test is to determine the convection characteristic of the given soil on site. The apparatus for this test is the sand condensity, a mold, a hot plate, a scoop, a caliber, and a small excavation tools, a balance, and a clean and dry non-cement sand. So first you need to obtain the density of the sand. So we need to measure the diameter and the height of your mold, and we make sure the condensity opening is locked. Then we fill the sand till it full, and then we measure it by using a balance.
Hello, my name is Brony Malantika Nagret. Okay, I'm the next presenter for the Sand Replacement Laboratory for Geotechnical Engineering. Okay, I'll present the video first. Okay, put the sand cone with the apparatus. Okay, after we fill the mold with apparatus with sand, and then we put it outside the mold and release the handle to let the sand flow down. Okay. Okay, then when the flow stop, lock the opening. Measure the mass of the apparatus with the remaining sand. Okay, and then for the next step, we remove all the extra sand at the top of the mold. O- Okay, measure the mass with the mold that has been filled with sand. Then take the reading of the measure weight. Okay, and then repeat again. Fill the apparatus with sand. Then place. Okay, then for the next step, place a plate that has been a hole at the middle of the plate at top of the soil. Then excavate the soil. Excavate the soil with the excavate material, such as any blade that we can use. Okay, we excavate until 15 centimeter, yeah, for this soil. Okay. Okay, and then we measure the weight of the excavated material. As we can see from the rear, it's soil. And then we take some sample to measure the water content. Okay, that's all for my part, and I would like to pass this presentation to the next person. Thank you.
Now, place the sand condensity apparatus on top of the hole of the soil that we have dig just now, and then we release the handle of the apparatus to allowing the sand from the apparatus to fill and flow into the hole. And when it stops, we take out the apparatus just now, and then we need to measure the mass of the apparatus with the remaining soil. Next, after we're doing our work just now, we need to make all of the calculation based on our data just now, okay? Now we need to find the value of bulk density of the sand in gram and also the mass of the sand in con gram, okay? To find this, we need to subtracting the value of mass of the mold with sand with the mass of the mold, and then the answer later will be divided by the volume of the mold, and the final answer for this bulk density of the sand will be 1.421 in gram. All right, after we're done with our bulk density of the sand. Now we need to find the mass of the sand in the cone. To find this, we need to minus the mass of the apparatus with the sand before, with the mass of the apparatus with the sand after. Okay, so two of these answer later will be minus with mass of the mold with sand and mass of the mold empty, and the answer later on will be 448 gram.
Hello sir, my name is Dominic Awana Jonas and I will continue with the calculation in the site for the sand replacement method. Alright, so we have water content that has been determined, that is 0.23. So the mass of the sand that filled the hole need to be calculated. To do that, we type equal, open bracket, insert the mass of the apparatus plus sand before, we minus the mass of the apparatus before with mass of the apparatus after, and then we close bracket, and lastly we minus it with the mass of the sand within the cone, so we can get 261.6. So next, for the volume of the hole, we know that volume is equal to mass divided by density, because density is equal to mass over volume. So to find volume is mass over density. So we type equal, then insert the mass and divide it by the density. Alright, we get 236.886. So we need the bulk density of the excavated soil. So we press equal, and then weight of the soil, which is 261.6, divided by volume. So that's the answer. And then lastly, we need the dry density of the excavated soil. So dry density is bulk density divided by 1 plus with water content. So we press equal, and then we insert the bulk density divided by 1 plus water content. So that's the calculation for the sand replacement method. So for the conclusion of this sand replacement method, we can conclude from the test is sand replacement is to determine the in situ density of natural or compacted soils using sand pouring cylinders. So that's all for our presentation video. I hope you enjoy it, sir, and thank you very much.